This is the video lesson for average velocity and average acceleration. The learning target for this lesson is, I am learning to describe the concept of average velocity and average acceleration. The success criteria for this lesson are, I can describe average velocity in terms of displacement and time. I can describe average acceleration in terms of a change of velocity and a change of time. And I can describe instantaneous velocity and instantaneous acceleration. So what is average velocity? Average velocity we can think of as a displacement of an object divided by the amount of time it takes for that displacement to occur. So the equation for average velocity is V average equals delta x over delta t. So velocity is a vector, so it has the little arrow over the V, and displacement is a vector as well, so the delta x, the x has a little arrow over it as well. So what is average acceleration? Average acceleration is a change in velocity divided by the amount of time it takes for that change in velocity to occur. So the equation for acceleration, or average acceleration, is average acceleration is equal to delta v divided by delta t. So again, acceleration is a vector, so it has the little arrow over the a, and then the velocity is a vector, so it has a little arrow over the v. So how do we know when an object is accelerating? So acceleration is a vector quantity, which means that it has both magnitude and direction. So the magnitude of the velocity can change. So the change of magnitude can be a change in speed, or the object can change direction. So either of those two things can happen. So the object can speed up, that's a change in speed, or it can slow down, or it can change direction. Either, if any of those conditions are taking place, then the object is accelerating. So one common misconception is that something is accelerating. That means it's speeding up. In physics, we consider acceleration to be both speeding up and slowing down. So let's talk for a second about instantaneous velocity and instantaneous acceleration. These are different ideas than average velocity and average acceleration. So when we're calculating average velocity or average acceleration, we're talking about the acceleration or the velocity over a very small time interval. And we can come up with that by thinking about very close to the instantaneous velocity or instantaneous acceleration. So if we calculate the average velocity or average acceleration over a very small time interval, then we're coming up with the instantaneous velocity or the instantaneous acceleration. So here in this graph, we are calculating the average velocity. This is a position time graph, so we're calculating the average velocity. And here we're looking at a pretty wide measurement of the time. So you see here, we've got a time here and a time here. So this is a pretty wide example. Time 1, time 2. Here we're getting closer. Our time calculations are closer to each other. So the amount of time that we're measuring between to measure our velocity, to measure our average velocity, is getting closer and closer. So we're getting closer to an instantaneous velocity rather than an average velocity. And then here we're getting much closer to an instantaneous velocity. We're measuring our slope much closer together. So our time interval here, our delta t, is much smaller than it was when we were first measuring our slope way back when we chose a position here and a position here. So if you think about in calculus, you start learning how to do differentials. You start learning how to take the derivative of an equation. If you have the derivative for the position of an object over time, when you take the first derivative of that, that gives you the velocity. And that gives you an instantaneous velocity. It gives you the instantaneous velocity for that object at a particular point in time. If you take the second derivative, that gives you the acceleration of that object at a particular instant in time. So what have we learned in this lesson? We learned about average velocity, which is displacement divided by time. We learned about average acceleration, which is a change in velocity divided by a change in time. And we learned about instantaneous velocity and instantaneous acceleration, which we can calculate when we're calculating average velocity or acceleration on very small time frames. That's approximately the instantaneous velocity or the instantaneous acceleration. All right, everybody. Thanks very much.